right, folks, so when you open the app on your computer, it should look like this. You need to download the video that I made. Hopefully you don't have a problem with that. And then to your laptop, and then you're going to import that video. And so I'm selecting roller coaster 1, and you should see this. And so I'm going to follow along with the directions by number. All right, so the first thing you need to do is set the scale for the video. So that's under System, and the default is a meter, that they're assuming you might have a meter stick somewhere in this video, and you're just going to, line this up with the meter stick. Long story short, I wanted to zoom in to see this really well so you can see when the ball lost contact. So this made more sense to me. You're going to line this calibration stick up with the Jenga block tower or container, and you're going to type in 0.273. I'm not going to do that because I want you to take your own measurement. So I'm just going to type in 0.42 so that the numbers aren't the same. Okay, and then I had trouble figuring out how to undo it. Then we want to take some distance. Then we're going to take some distance measurement. Nope, we're going to do the trails. Then go to trails, and this is the cool part. You are going. Oh, sorry. When you open up the video, it might look like this. I really want you to try to make this as big as possible so that you have the highest resolution possible, so that you get the best data possible. All right. So try to do as full screen as you can. And then you click the trails, and what you're going to do is, sorry, you always forget this, you have to add a trail. And then you're going to get this little bullseye. You want to find the center of mass of the golf ball. So click on the golf ball. It should advance 1 frame. This first one is slow, then it gets better. Okay. Then you're going to click on the center of the blur. You're going to click on the center of the blur. You can see, I hope, that it's getting faster. And you're going to keep clicking until about here, and then you want to try to notice if it's losing contact or not. Let's click one more time. Definitely, I think, lost contact there. If you keep going, let's see, let's move this up. You can go forward a frame and see definitely lost contact, so you can go back and forth and go, all right, you make the judgment call of where you think it lost contact. Okay, I'm going to go with that one. And then you take a screenshot of this to show me that you took data, and that's worth 8 points. Okay, and then we're going to use, so we're done with the trails. I learned that if you make a mistake, you can edit, you can grab any one point, and you can actually move it if you want to adjust it a little bit, but you can just throw it in the garbage too. Okay. Now we're going to go to System, and you only set the scale once, right? That's just basically saying something of known measurement is this big, so that the computer program can adjust. Okay, so please do that carefully. We did that with the Jenga block tower. So don't use this scale. Now we're using distance. And we're going to take a couple of measurements. What you want to really try to do is find... Oh, so I guess it randomly made this ruler. You're going to grab it. You really want to find the flat diameter of the track. All right, which is, in theory, should be, if you moved it up a little bit, keeping this horizontal, it would shrink, right? You want to find the spot that's the biggest. And the track is actually kind of a V shape, so you don't want to go to where you first see aluminum. You kind of want to go to the midpoint. Again, not maybe more accurate than trying to do this by hand. Anyway, so that is, again, the wrong diameter, but you want to write that down. Then we want to grab another ruler. So you just kind of click and it appears. It's a little bit wonky. And then you want to measure the distance from, you want to measure the hypotenuse. So this, you're kind of want to guess where you think the center of this is. I don't know if you want to, no. So let's go to that. That's your hypotenuse. Okay, so write that down. And then you want another ruler. And you want to go from the golf ball vertically down. So hopefully this makes sense. What you're trying to create is this triangle here so we can get that theta. Okay, so you have your hypotenuse and you need this 0.14. Okay, so you need to record those actual measurements. You need to record the diameter, and you're going to copy these values to your lab paper. Hopefully that makes sense. Okay, then you're going to do some inverse trig to find that theta. You can do that all on paper. You're going to do one last thing with the video analysis. So we're going to move the video over, and what it did was whenever you clicked, it recorded the time because it knew how quickly the frame rate was, and the X location and the Y location. It took the derivative of these things and gave you the X velocity and the Y velocity. So we're going to click on the, I think they call it skewer pop-up menu, and we are going to add a calculated column. And this is the velocity of the ball, the total velocity in meters per second. And we're going to insert an expression, and what we're going to do is we're going to take this square root of not y velocity in time, but x velocity and y velocity. So we haven't talked about velocity vectors yet, but hopefully that makes sense. The golf ball, when it loses contact, is going a little bit to the left and a little bit up, but the actual speed is the hypotenuse. It's the a squared plus b squared square root is the total velocity. And we're going to apply that. And you're going to read down to your last data point. So scroll all the way. So that is my last. Okay, yeah, so it covered up. I'm like, I know we took more data than that. So make sure you scroll all the way down. That is the velocity of the ball, 1.71. So you're going to write that down. That is your answer to question 9, and I'm calling it the click velocity. That's the velocity that the computer calculated based on you clicking on the position at any point. Okay, so that is based on your click decisions. That's the click velocity. The velocity you're going to calculate, which I'm calling the ruler velocity, is based on this triangle so that you can get theta, so that you can break down your mg and do your radial column, which was the whole point of practicing. But I do think it's kind of cool that hopefully you do too, that when you play this, you can see, I don't know why it's not, you can see the speed, you can see that the trails change. I don't know why it's not showing the trails anymore, but sometimes you have to turn them on. Anyway, we really just needed the dimensions, but I think it's sometimes people videotape athletes using this method, or if people are making those movies where the animated people look really lifelike, sometimes it's because they have real people wear suits with these glowing dots, and they instead of clicking on spots, they show you the different locations, and that's what they. I don't know if that's making sense, but that's how they make it look lifelike. I don't know why the trails isn't showing up, because it's cool to see. Anyway, hopefully you saw that before. All right, so reach out if you have questions. There it is, so that you can see the path that it made, and that it was speeding up and then slowing down because of losing energy. So the spots were getting farther apart as it sped up and then closer together as it slowed down. So that reinforces what we're doing in this unit. All right. Please feel free to reach out to each other with technical questions, but I really do want this work to be your own, so that I feel good about giving you credit for it. So again, please reach out if you get really frustrated. Save it and come in for office hours. But again, reach out to each other for technical questions, but do your own work. All right. Thank you for listening.